So in this video, we will learn about Kubernetes technology and how we can use it for deploying our Django app. In the first section, I will briefly introduce Kubernetes technology. It takes a little time and our focus is on the coding section. I will use the Minikube application to set up a virtual cluster on my PC. After the introduction, we will dive into the code and deploy a simple Django app over the Kubernetes cluster. First, we are going to deploy our Django module. Next, we deploy our Postgres database, and then Redis, and finally Bit and worker of Celery module. So stay tuned to see how we can deploy our Django app over the Kubernetes cluster. By the way, I publish tutorial videos about backend and DevOps fields weekly. So please subscribe to my channel to be informed whenever a new tutorial comes out. Okay, so let's dive into the quick presentation of basic concepts of Kubernetes. We are going to cover these criteria in this presentation. First, we will see what Kubernetes is. Second, we are going to compare it with Docker technology. Third, we will discuss some pros of it. Fourth, we will learn about its architecture and basic components. And finally, we start our coding section and deploy a simple Django app over a Kubernetes cluster. So what Kubernetes is? Containers are a good way to bundle and run your applications. But in the production environment, you need to manage the containers that run the applications and ensure that there is no downtime. For example, if a container goes down, another container needs to start. It would be easier if this behavior was handled by a system. That is how Kubernetes comes to their rescue. It takes care of scaling and failover for your application. So Kubernetes is an open source container management tool and was developed originally by Google and can manage containers on different environments like virtual machines, physical machines, and hybrid ones. So another important question that learners come across is what difference it has with Docker technology. Actually, Docker is a container technology, while Kubernetes is a management technology. Docker is about automated building and Kubernetes is about automated managing. Okay, so why should we learn it? Container management tools like Kubernetes have pros that businesses with giant users should consider. The first reason is high availability with minimum downtime that they provide us. If one of our containers goes down, another container will be prepared quickly. Another reason is the scalability that they provide us. For example, consider shop applications that sometimes have many more users. They can easily scale up their application when needed and scale down when they did not. Okay, so we need an orchestration tool for our application. Why should we choose Kubernetes? There are other orchestration tools like Docker Swarm. First, it has a great data management tool named Kasten that you can use for taking backups from your cluster. And second, it has a bigger community in comparison to other competitors. So now let's talk about basic architecture and main components of it. Kubernetes runs our workload by placing containers into pods to run on nodes. Depending on the cluster, a node may be virtual or physical machine. Each node is managed by the control plane and contains the services necessary to run pods. Kubernetes follows a master-slave architecture and has a master node and multiple worker nodes. Each node has a kubelet process on it, and in the cluster, nodes can talk to each other by using kubelets. Each worker has a different number of containers depending on how you distribute workload between them and how many resources each worker has. A cluster have different components in it, but the common components are pod, service, config map, secret, volume, and deployment. So now let's see what each of these components do. Pod is an abstraction over container. Service provides access to the services in the clusters like pods. Config map provides a non-confidential key values to the pods. Secret provides confidential key values to the pods. Volume provides permanent storage to the pods. And deployment provides declarative updates for pods. So we can scale, we can increase replicas or decrease replicas of each pod. Now let's dive into the code and deploy our simple Django app that we created in the past tutorials with Kubernetes technology. Okay, this is the project that we created through the past tutorials. It's about a shop with just one app and one model named product. It has a Celery task that makes thumbnails from product images. We deployed this project by using Docker Compose technology in the past, and now we want to use Kubernetes technology. So we will have two ways to deploy our app, first using Docker Compose and second using Kubernetes. We should mainly use environment variables to specify different settings in these situations. I will use Django environment package to read environment variables because it can automatically convert strings to specific data types like booleans, and it makes things for us easier. Notice that when a new package is added to requirements, we should rebuild the Docker image and upload it to the Docker Hub. As you can see, I read some variables from environment variables. You can easily convert them to the boolean. Also, we are going to read the database and Redis configuration from environment variables. Now let me create a new branch to develop our Kubernetes deployment in a different branch. Then I want to create a new directory, especially for Kubernetes configs. Then create a directory for storing Django related configs. Okay, now I want to start with config map configuration, in which we define our not confidential variables. We are first specifying the API version. The Kubernetes API lets you query and manipulate the state of API objects in the Kubernetes. For example, pods, namespaces, config maps, and events. Different objects have different API versions. Next, we specify the object type and then metadata that we assign name, shop, config, key value to this configuration. Then we define key values data. We will define debug variable, Redis host variable, and DB host variable. These variables are not confidential, so we define them in the config map object. Now we want to use this configuration and insert it into our cluster. To do that, we should have installed Docker and Minikube on your machine. Minikube is a tool that provides us a virtual cluster in our machine. Now we want to start our virtual cluster. Before that, you should have run the Docker application. I use the Minikube start command to run the cluster. After that, we can use the kubectl command to manage our cluster. We can use the get all command to get all configuration objects. We use the apply command with the -f option to apply file configurations. So we specify the path of the file and then hit the enter. As you can see, kubectl in the response tells us that configuration is created successfully. In the next step, I want to create a secret object. Similarly, we had defined credentials in the .env file for deploying our app with Docker Compose. Now I want to create a new file containing the credentials we need for Kubernetes deployment. Here I will define just Postgres password and secret key values. Now I'm going to create secrets from this file using the create secret command. Be aware that we consider two types of environment variables in here. First, we define non-confidential variables in the config map object, and second, confidential variables that we created with this secret command. You can check secret objects using the get secret command. Then by using the describe command, you can see the variables in that secret object. Now let me add the env file to our .git ignore, so we will not publish it to our repo. In the next step, we will create a deployment configuration for our Django app. Deployments create pods in the cluster. The key value app shop is label that we give to this pod. We can specify replicas here and scale up or down with this setting. Here, we determine which image should be used. We also specify environment variables that should be retrieved from which sources. We will fetch them from secret and config maps. We will open port 80 where our Django APIs are accessible. Now we want to specify a shared volume accessible to other pods. So we want to mount the pods path /app/shop/media to a specific path in the cluster. We will store our media files like product images in them. To use volume in the cluster, we should use volume climb. Later, we will see how we create persistent volume and persistent volume climb. For now, consider that we mount the media path in the pod to a volume in the cluster. And for using that volume, we specified a climb named media PVC. Now we are going to create a persistent volume resource in our cluster. We define a storage class name as manual value for the persistent volume, which will be used to bind persistent volume climb requests to this persistent volume. We give it 2 GB capacity and specify read-write once access mode, meaning the volume can be mounted as read-write by a single node. We also specify that volume should be at /data/media PV on the clusters node. After creating persistent volume, we should create persistent volume climb to use that volume. Using this way, we say we want a persistent volume with 2 GB capacity and read-write access mode in this cluster. That is exactly what we provided in the previous step. Next, we will define a service configuration for Django app. By doing that, we can access port 80 of the Django container. For simplicity reason, we will use load balancer type service and map port 80 to 8000 port. So our Django app will be accessible at port 8000. Next, we will apply the deployment config that we had created before. We have some intention problems and can successfully apply them after fixing them. Now we are going to create our database configurations. First, I will create persistent volume. It's similar to the media volume that we created before. Next, we will define persistent volume climb, so we can use that volume. Next, we are going to define the deployment for the database. For simplicity, we want just one replica. We will use the Postgres 14.4 Alpine image and pass the password from the secret object we created in the past. We also mount the path where Postgres stores its data, so it will be permanent. Next, we should create a service for that database so it will be accessible by other pods. So Postgres will be accessible at port 5432. Now, we will use the get pod command to check whether all pods are okay. As you can see, Django app and Postgres app are in running status. Now that we prepared our database, we should first migrate our migration files. So I'm going to the Django container and migrating the database. Now let me check if our APIs are accessible and work correctly. Okay, so it's not accessible. One thing I forgot to mention is that we should run the Minikube tunnel app to access load balancer services. So let me start the Minikube tunnel app and test the API we provided in the past tutorials. Okay, now you can see that our list API works correctly. In the next step, we should set up our Celery configurations. First, I will create a deployment configuration for Redis. As you know, we need Redis as a message broker for the Celery module. You can also specify how many resources a deployment will need. When you specify the resource request for containers in a pod, the kube scheduler uses this information to decide which node to place the pod on. Now I will create a service for the Redis to be accessible to others. Okay, now I should create Bit and worker deployment. As you know, we use the same image with a different command for Bit and worker. Here we first go into the proper directory and then call bit command. Now let me apply this deployment. Next, I will create the worker deployment. The worker will have the same deployment configuration, and we will just make changes to its command and add media volume to it. The worker needs access to media volume for things like image processing. If you remember, in the past we had created a Celery task that makes thumbnails from product images. We should provide volume mounts for its deployment to Celery access these images. Now let me check our product creation API works and whether Celery can create thumbnails from the product image. You can see that the product was made and its thumbnail field is null initially. Now we can see that the thumbnail was also created. We also can check the pods logs to see if they had any errors. Thanks for watching this video. I hope it was helpful. If it was, don't forget to like it. If you want to be notified whenever a new video comes out, then subscribe to my channel. If you had any question, please post them in the comment section in the below. I will try to answer them as soon as possible.